I have KNN. Click on the KNN, and inside KNN, I have project 1, that is understanding fundamentals of KNN. So click on this file so that we can open our project 1 in our Google Colab environment. So here I am in my project 1 of KNN. So I need NumPy for this project. I need pandas. I need matplotlib. I also need a function make_blob. This will help us to create the dataset, and I will import it from sklearn.dataset. Similarly, I need k-neighbors classifier, which I will import from sklearn.neighbors. I also need train test split function so that I can split my data into training and testing component. So let's run this cell to import all these Python libraries and Python functions. Now it's time to create the data. So I am going to use a function make_blob in order to create the data. So I have to pass few input parameter. The first of all, how many samples I need. So in the first step, I am passing number of samples is equals to 10. Number of features is equals to 2. Centers is equals to 2. So the centers is equals to 2 means that when I will run this line of code, it will generate a data which belongs to 2 classes. So centers equals to 2 means I need 2 classes for this data set. Cluster standard deviation. This is another important factor. It is 1.5. It sets the spread of the data. Basically, I will generate that data with 2 labels, and the samples belongs to both these 2 labels will be apart from each other. So how far apart those 2 samples are from each other, it will be set by the cluster standard deviation, which is 1.5. So the random state is 42. It means I am passing the random state so that every time I run this line of code, I will get the same samples for my features and for my labels. Let's run this cell to create the data. Let's see the features in the data. So we have 10 features and basically 10 samples, and we have 2 features in our data set. This is the column 1 or feature 1. This is the column 2 or a feature 2, and we can see that we have total 10 samples. Okay, if we want to confirm the shape, we can confirm the shape by writing x.shape. So we have 10 samples and 2 features. Now we can also check the shape of our labels. So we also have 10 labels. Since we have 10 samples, so for every sample we have a label. Therefore, we have in total 10 labels. Now, how many unique labels we have? So if I run this line of code np.unique and I pass the label, I will get 2 values, that is 0 and 1. So we can see that I have 2 labels, 0 and 1. So basically here I have passed centers is equals to 2. That's why I have 2 labels in my data set. So the first part is completed. That is, we have created the data set using a function make_blob. And when we run this function, we get the value of x and we get the value of y. X is feature and y is our label. After creating the data, it's time to visualize the data. For visualizing the data, I have set the figure size 12:8. And now I am going to plot 2 scatter plot. This is the first scatter plot, and this is the second scatter plot. If you see here, there is a 1 and there is a 0. Here again, there is a 1 and here there is a 0. So basically, I am going to plot the second feature against the first feature. And again, I am going to plot the second feature against the first feature. Because if we go back, we can see that we have 2 features. So I am going to plot the second feature against the first feature. Now, why there are 2 scatter plots? The reason is that I am going to plot the second feature against the first feature for those values of y or for those values of x which belongs to y equals to 0, that is label 0. And I am going to plot second feature of x against the first feature of x for those values of x which belongs to y is equals to 1. Let's understand the concept of these 2 terms here. So if I write x and then I write y equals to 0, what I will get? Let's see. So I will get 5 features, basically 5 samples. Out of 10, I will get those 5 samples which belongs to label 0. And if I write y is equals to 1 and I pass this into the index of x, I will get those 5 samples which belongs to class 1. So we have total 10 samples. out of which 5 belongs to class 0 and 5 belongs to class 1. Okay, so if I write y is equals to 0 and I pass this as an index of x, I will get those samples of x which belongs to class 0. Okay, and if I pass one more 0 after the comma, it means, let's run this cell, it means I will get those sample of x which belongs to y is equals to 0, but they are present in the first column. If you see these value -3, -0.1, -2.8, -3, -0.1, -2.8, these values are present in the first column. So basically this means belongs to class 0, and this 0 means present in the first column. So in order to represent first column, we need to write 0 because index in Python start from 0. So if you see here, what is this? It means these are the samples which belongs to class 0 but present in the first column of x. And these are the samples of x belongs to class 0 but present at the second column of x. Similarly, these are the samples of x belongs to class 1 present at the second column, and these are the samples of x belongs to class 1 but present at the first column. So basically, this is the understanding. So what I am going to do in the scatter plot, I am going to plot the second feature against the first feature, but those samples which belongs to class 0. Then in the second scatter plot, I am going to plot the second feature against the first feature, but for those values of samples or feature which belongs to label 1. Let's run this cell and visualize the scatter plot. So we can see that we have 5 samples here and we have 5 samples here, and there is a difference between them which is according to this cluster standard deviation. So we see that by using a make block function, we can create a data set and we can pass any number of samples, any number of features, and any number of cluster and any value of the cluster standard deviation. Then the important thing is how to visualize the data. For visualizing the data, we have to do 2 scatter plot, or we have to plot 2 scatter plot. That is the scatter plot between the second feature and the first feature. Why we need to plot 2 scatter plot? Because the first plot will be the second feature against the first feature for those value of x belongs to class 0, and the second scatter plot is against the plot of a second feature against the first feature with those value of x belongs to class 1. So in this way, in this lecture, we learn how to create the data with the help of an important function make_blobs, and how to visualize the data using a scatter plot. We also learn why we need to plot 2 scatter plot on top of one another. So I hope you understood this lecture. I stop project 1 here. In the next lecture, I will continue my project 1. See you there.